Welcome in LwCad 2020 video for Cinema 4D. My name is Viktor Veličko, and in this video I'll try to explain you and show you the essentials of LwCad plugin and how this plugin can be useful in your production pipeline. This video is divided into several chapters. First, LwCad Basics. This is essential. I highly recommend to watch this first and carefully. Then in Ucs and Snapping chapter you can see the differences between snapping and workplane in LwCad and Cinema. Also in real-time Booleans chapter the Booleans are explained. In UV mapping chapter you can see how easily you can create UV maps, especially with architectural objects. And the rest of the chapters are about specific archviz modeling for creating walls, floors, windows, roofing, stairs and railings. In final chapter I will explain current status of LwCad project in Cinema and what you can expect in next versions. LwCad Basics. In this chapter I would like to show you some basic information about LwCad plugin and how you can use it in Cinema 4D. If your plugin is installed properly, you should have this LwCad toolbar with LwCad icons. First, LwCad options. In LwCad options section you can set some basic options for LwCad, such as units, some snapping options, mouse options, and after clicking into viewport you can see also OpenGL buttons which can be enabled, disabled for each group, and you can also set the size of these buttons. These buttons are essential for LwCad because they're raising productivity of modeling. Very useful are also these shortcuts to support and discussion forum about LwCad. So you just click on the shortcut and you are logged in on the LwCad web page with your details, and you can use directly support. LwCad is using three basic plugin types. First, parametric objects. Second, tools or utilities. And third, commands. Let's start with parametric objects. When you activate parametric object, you switch the tool into creation phase. In creation phase, you can adjust snapping, UCS and auto parent parameters in attribute manager, and you can create the object with left mouse button by clicking into viewport. So when you click into viewport, the object is created, and now tool is in edit phase. In edit phase you can adjust all the handles of the object, newly created object, and you can also adjust all parameters of the object in attribute manager. After you click right mouse button, you will end current edit phase and you can start another object. So now you are again in creation phase of the same parametric object, and you can create another object. Again, right mouse button will end this object, and with left mouse button you can start another edit phase of next object. This way you can easily create a lot of objects and place them immediately on the position you need. So together with snapping and UCS, automatic UCS, it is very powerful system. If you drop creation of parametric object completely and you select a created object back, you can switch back to edit phase of this object by activating edit phase here. And now when you are switching between objects, you are still in this edit phase of actual object. So as long as you keep the parametric objects not converted into mesh or polygons, you can still adjust all parameters. Auto-parenting system is very important for connecting objects automatically. So you can enable auto-parent in creation phase, and then when you first time click and create object, then this new created object is automatically connected as a child to the previous parent object. This is one way how to connect. Then if auto-parent is disabled, you can create object and connect it with, let's say, this setParent cinema tool. So this is second way, and third way is to manually drag this new created object as a child to this box. So you have three ways how to connect new parametric objects to another object. We have three basic types of the objects, parametric objects: object, parent modifier, and child modifier. Let's take a look on the examples, the differences between those objects. Simple object such as box, stair object, or railing object. This doesn't depend on the child or parent. The geometry is generated only from parameters and the shape of the tool. When you attach one box to another as a child, then the child object, when Boolean mode is enabled, let's say subtract mode, the child object becomes the parent modifier. So in this case, child doesn't create any geometry, only a parent box is modified by this child object. So child object is subtracting into parent. So with automatic link, you can this way drill with child objects into parent. This is very nice example of parent modifier, and if you freeze or convert these objects into polygons, all child modifier which are not generating geometry itself are deleted, only remains the box which is modified. Now let's try some examples of child being modified by parent. A very nice example is a floor tool. Floor tool, when you attach it to another object like box, the floor is generated from the parent. So when parent is modified, child object is recalculated from the box. Another example is the stair rail. Stair rail object, when you attach on this stair object, the railing is calculated from the stairs. So when you modify or adjust the stair object, the railing is recalculated. So stair is modifier of the child object stair rail. The last example I'll show you is the window tool or window object. This is a special case of a parent modifier and a simple object or a simple parametric object, because window object, when attached to the wall, it is the modifier of wall, parent object wall, and at the same time it also generate geometry, the windows geometry. So it is both parent modifier and also object. This is the special case. Now let's talk about the tools. When using tools, you need to know two basic important information. First, that only selected object can be modified. So you need to first select some object, then apply tool. In this case, only box 1 is selected, only box 1 is moved. And if you select two objects, box 1, box 3, both these selected objects are moved. Second is that you can use also polygonal selection. So if I select these two polygons of selected box 1. Then when you apply move tool, but now you have to switch from node mode to mesh mode. You will apply these two polygons, and if you are moving polygons in mesh mode, then only selected polygons will be moved, as you can see. So these two information are most important, that all tools works on only selected object, and you can use also polygonal selection on different level of how you apply these tools, each tool using this polygonal selection different way. And finally, the commands. Commands works pretty same way as in Cinema, but I want to show you two very important commands in LwCad. First is conversion LwCad object to polygons, and second is conversion of polygonal objects or Cinema objects into LwCad object. If you create Cinema box or polygonal object and you want to apply some LwCad primitive which needs to be modified by parent or modify parent, it is better to use it on LwCad object, because for example, if I use this box on Cinema box, use it, set it as child, the Booleans are not enabled now because it doesn't work with Cinema object. Therefore, you need to convert Cinema box into LwCad object with this command. It's just one click, and then you activate the box again, and now you have enabled all the Boolean modes. So this way you can apply any LwCad object to any Cinema generated object. So you can just convert it into LwCad object and you can apply. The second command for conversion of LwCad object into polygonal object is even more important, especially if you are using parametric objects which are dependent on a parent or a child. You have to use this conversion command, because if you apply it, it will convert all object properly and delete remaining modifiers which should be deleted. Cinema conversion doesn't know how to handle this properly. UCS and snapping are the backbone features of LwCad plugin. UCS is in every parametric object and every tool. You can enable automatic or fixed UCS mode. When automatic in choice mode, the UCS is automatically placed under the mouse, hitting the first polygon, and it is aligned to the viewport. You can quickly change mode with short key A and short key F. So you can switch to fixed mode. When UCS is red, it is fixed. If you hit short key A, you are back in automatic mode. So this is a very easy way how to set up the UCS quickly before you create object. Now when I fix UCS here on this polygon, you can create very easily more objects, and if you need to switch to another, you just hit A short key again, hover with mouse to other place and hit F key again, so it is frozen, and again you can create object on this UCS plane. Very useful UCS option is also auto corner. Default is left down. You can put it into, let's say, right down corner. So now anytime you hit the polygon with auto UCS, the UCS is trying to set origin of UCS workplane into right down corner. Default is left down. So this way you can change the alignment of the UCS pivot. And now let's take a look to a snapping system. snapping system is very well synchronized with the UCS, and only limitation of current version is it works only with polygonal objects, but it will be heavily updated with next version when NURBS objects will come. And I will not go into detail now, just show you some most important snapping modes. Grid snapping is very useful when you're placing windows on the walls, for example. Edge point and surface snapping are pretty standard and doesn't need to explain this. Maybe some interesting is the angle snap. Angle snap, you can set the angle, snapping angle here in attribute manager. I will leave it as a 45 degrees. Angle snapping can be triggered with a control key. So if angle snapping is disabled, you can hold control key and it will be enabled only to the time until you hold control key. As long as you release control key, angle snap is disabled. If you enable permanently angle snapping, you don't need to hold control key. This is very useful for snapping, for some snapping situations. Also very useful is the intersection snapping. It intersects right now only the intersected polygonal edges. Also perpendicular snapping, snapping again to polygonal edges, and also roller snapping. Roller snapping now works only with edges of polygons, so you set roller division, let's say, to 10, and this polygon edge is divided into 10 pieces and you can snap on them. This is very useful. Real-time Booleans. In LwCad we have two possibilities how to do Booleans, destructive or non-destructive way. Let's start with non-destructive way. Each primitive, parametric primitive, can be triggered to be a modifier of another object. So let's try with this box. If I enable automatic linking and I create box on this original box, it is automatically linked as a child, and now if it is linked as a child, you can enable a Boolean operation, let's say subtraction. So this way you can do non-destructive Booleans with automatically linking. It is pretty fast operation how to do Booleans, and these Booleans are still non-destructive because anytime you switch back, let's say this sphere, you can adjust each step of the Boolean. But once you select this and convert into LwCad object or into mesh, so let's freeze them into mesh, now it is destructive. So you no longer be able to adjust these Booleans. Another very nice example of non-destructive Booleans is a window tool or window object. Window object is automatically attached to the wall as a child, and it is automatically doing the subtract operation to the wall. So as you can see, very useful implementation of non-destructive Boolean directly into parametric object, architectural parametric object. Destructive Booleans can be used with any object. It just needs to be converted into mesh or LwCad object. So let's say these two polygonal boxes. In current version we have only these cut tools to provide destructive Booleans. So let's say this rectangle tool. You can apply this rectangle to both objects at once. You can subtract, you can intersect, and you can slice. And slicing operation can be done in 2D or 3D mode. In 3D mode it's slicing everything, and in 2D mode only these two polygons which are lying on two work plane, two UCS work plane are affected. So as you can see, very flexible, very quick to use, and very useful. UV mapping. Even Cinema has a very powerful UV mapping system. LwCad is offering 3 additional tools which gives you additional power to existing UV mapping tools. With rectangle and quad UV mapper, you can apply UV maps and material directly on objects and apply also materials at the same time, and randomizer will give you power to randomize some UV maps to make UV maps more realistic. So let's go and try these tools on objects. First you have to have selected a mesh object or LwCad object, same as with CAD tools. Once you have selected, you can apply, starting with rectangle UV mapper. You need to create the tool, and now with the rectangle tool you can adjust a rectangle tool which is linked to the size of the UV map, and we have several different modes how to use this tool. So first mode is polygonal mode. Polygonal mode will apply UV map and material to the polygon which was under the first click when tool was created. So in this case it is this polygon. If you switch to plane mapping, then all polygons in UCS plane are mapped and surface is applied. If you switch to projection, then it will project UV map and the surface to all front-faced polygons along the UCS or work plane. For projection mapping, you can switch also to back projection, so not just front polygons, also back polygons are mapped. And finally, we have all polygons mode. In this case, everything is UV mapped, everything is applied with surface. Some options in the rectangle tool are specifically very useful, like rectangle mode. You can switch between rectangle modes, center, corner, and rotate. In rotate mode, you can very easily align mapping to the any edge. And also very useful is the size preset system. So let's say I have this size of the preset, and you can use and save this preset 2.6 meter to 1.8, and you can save it, and anytime later, even in other project, you can load it back. This is a huge time saver when you're mapping a lot of different surfaces, a lot of different sizes of UV maps. You can just save it and then just reuse it anytime later. Next very useful UV mapping tool is Quad Mapper. You can create and apply UV mapping on quads, and you can expand the selection on these quads, and UV map will be stretched along this selection. You can change orientation, flip, and also you can use the same preset system to load back the size of the UV map which you have created with rectangle tool. And the last random UV tool is especially useful when you have already UV maps on objects and you are using seamless texture. For example, like this wood texture, plain wood texture, and you just apply this to this object, click into viewport, and everything is randomized. So the UV mapping is randomized. You can experiment with different rotation, scaling, and offsetting along U, along V, and you got the randomization, which might result in much more realistic result. And you destroy the uniformity of UV mapping with this tool. The wall and floor tools. And these both tools are very essential when you need to create main body of the building very quickly. Starting with wall tool, pretty easy tool to use. You just click, 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 and you have the wall. You can intensively use the snapping system, which really helps, especially the grid snapping. You can snap to grids. It helps to create wall quickly and precisely. Angle snapping is very useful when you need to align corners of the wall to certain angle, under certain angle quickly. Also, you can enable disable showing distance of segments, angle between segments. You can close last to first segment, delete last segment. You can set width of the wall. You can align wall to the left, to the right from the tool, to the center. You can set the wall material, generate UV mark. So this is complete parametric wall tool, very efficient, very quick, and very easy to use. And because this is a primitive, you can create another wall and attach it to previous wall and use Booleans, and you create one single wall created from two walls very easily. One more very nice feature of the wall is also, I will disable all this, is also end tangents. If you're modeling, let's say, without Booleans, you just need to each wall separate wall, and you want to align this ending of the wall, you just enable tangent option and you set the ending of the wall to fit how you need to be aligned, the end tangent of the wall. So this is also a very nice feature. The floor tool can be attached to any mesh or LwCad object or any parametric object created by LwCad. Useful is automatic linking, so you just click on the object you want to attach and the floor is created. You have several options here. You can create the floor, as a ceiling. You can do multiple floors. You can also set the thickness of the floor and offset of the floor object. So you can do a lot of combinations, but primarily this is for floor generation. And one very important feature of this tool is that it works also on objects which are modified. In this case, this floor we have attached to the wall, which is modified but by another wall with a Boolean modifier. So if you set this apply to parent to modified mesh, it will create floor from result of this original wall after Booleans. If you set apply to parent to original mesh, because it is attached to the original wall, now it is creating floor only from original wall before Booleans. You can attach this floor to any other frozen polygonal mesh or any other LwCad object as well. So also very useful, quick, and really fast to use tool. Windows. We have two versions of window tool. First, window tool. This is legacy tool which is using shape library. It can create windows and doors and frames in 3 layers. It is pretty good tool, but it is legacy tool which was originally designed for Lightwave. Second version, the window tool. It is a fully parametric tool which is generating windows just from parameters. You can very easily use it by clicking to wall with automatic link option, of course. This way the window is automatically attached as a child to the wall, and it is automatically drilling hole into wall and creating window as a separate object. Now I will go through every parameter of this tool, and I will explain every parameter, because this is essential tool. First, I will disable all parameters, and we can go each parameter step by step. So let's start with glass. If you enable glass, you have just plain glass. You can set the thickness of this glass. If you set this to 0, it will be 1 quad polygon now. Next option is the inner frame. When you enable inner frame, then each table of the glass is framed, and you can set the size of this frame and depth of this frame, inner frame. You can change also divisions of the window, so you can change number of these tables. So if you set the horizontal and vertical divisions to 0, you have just one plain table. You can set the top shape of the window. Default is flat. You can set this as a triangle with different top slope. Also arc. This top slope can be arc, or triangle right, triangle left, or arc right and arc left. All these modes has a shared top slope parameter. Let's go back to flat version, and I will add some divisions. And now let's try the outer framing. If you enable outer framing, this is the second level of framing, then the outline of the window will have also frame, which can be also set as a size and depth. And the depth is calculated two ways, from window and from wall. So I will disable up edge so you can see the profile. Now it's better visible. So if I set the window calculation of depth for outer frame, then you are setting the depth of this outer frame around the window. If you set depth from wall, then depth parameter means distance from the wall out, in and out. So this is the difference: depth from window, depth from wall. Another neat feature of outer framing is that you can enable outer frame only to specific edge. So let's say I want this up, left, down, and not up, left, right, and not down framing. And this way you can create U shape of the outer frame. And the last option here is a sill. Sill is special version of outer frame, but especially for down edge. So you can enable extra framing to from the bottom, and here also you can set height. You can extend this sill also to sides, and also depth. Depth is calculated same way as for outer frame, so it can be calculated from window or from the wall. The window offset or window position within the wall can be changed with this window offset parameter. If you create the window on the corner, wall corner, like this, I will delete this edge. Then you can see there is extra button for corner, so you can enable corner mode of this window. So just enabling corner window, it is automatically recalculated to fit this window as a corner window. Also very useful feature is this fix button. You can remember or fix current size of the tool with fix button, and when you apply to somewhere else, it is created with same size. This is very useful. And now if I use the corner button also on the second side of the corner window, you can see how pretty nice corner window we have created. Together with fix mode, these both windows are identical, and also we have created very nice and clean corner. Roofing. In this version we have 6 different roofing tools. You can use all these 6 to create practically any roof within seconds. I'll show you on these 5 examples how to use these tools to create different results. Let's start with rectangular roof. First, using F key, I will create fixed work plane. And let's start with rectangle tool. So rectangle tool, I will use the corner mode to fit roof easy to stretch the foot on this object, roof on this object. If you want to extend the sides of this roof over this building or over this box, then use the center mode, and here width and height just use plus 100 centimeters, use plus 100 centimeters, and this will do additional half meter to each side. So this is precise way how to extend the precisely placed roof over some object to add some extensions, precise extensions, manual way. Next, let's create this rectangular roof again, and now I'll show you 3 different types of the roof. 3 possible. It is gabled roof, hyped roof, and side roof. So these are 3 basic types. Next, I'll show you how to do non-destructive booleans to create roofs. Create a one roof, proper align, create the second roof, again proper alignment, and now just use the set parent, second roof to first roof, and use add boolean. And this is example how to use non-destructive booleans with roofing primitives. In the next example, I will create the gabled roofs. So now change alignment and set this as a parent and use add booleans. Oops. Okay, now add booleans. This is next example. Here for this I will use example of line roof. Disable booleans. So you can see you can very nicely use all these handles to fit object. And the last manual way of drawing roof will be this object. So here I will create let's say the hyped. Okay, here this will be hyped. Do always proper alignment here, and on the sides I will use the gabled. Okay, I forgot to do boolean, so again here and use add. But as you can see, because I'm using auto linking, first click was on the building, so it is not properly linked, so I have to relink it manually. We want to do booleans with the roof, not with the object. So, and now the second, again relink, or disable linking, auto linking. In this case it's better probably. Now auto and use add boolean. Okay, so As you can see, this is the manual way of drawing. It is pretty fast, but very flexible. And now let's do the extend roof tool. You activate it with automatic link. You just click on the roof and extension is created. Right mouse button will end, and with left mouse button you can attach to another. Right mouse button, left mouse button, right, left, right, left, and with 12 clicks you create the extensions of the roof to existing roof. This tool is of course parametric, so you can adjust all the parameters. You can adjust extensions, you can adjust the thickness. So this way you can create extensions, and the shingles, most productive and most fast tool. With this same way you just attach to existing roof and shingles are created. So let's do it. And you can see beautiful roofs, really quickly done. So this is the one way of creating roof. The second way of creating roofs is with starting with floor tool. So same way, you attach floor with some extensions on these objects. Then use auto roof. Auto roof generates only half types of the roofs right now, so it's a bit limited, but will be updated in next versions to offer more flexibility. And we can finalize these objects again with shingles. So as you can see, way much faster than previous. And finally, the shingle tool is of course parametric. This is a bit complex parametric tool. You can choose between 3 already existing presets: Roman, Vienna and Modern. For most of the users, these 3 are pretty much enough, but you can create your own presets with your own shingles together with Add to Shape library. This is a bit complicated process, but it is doable. Stair object. In this version we have 4 stair primitives: rectangle stair, line stair, arc stair and spiral stair. So let's start with rectangle stair. You can choose between 3 stair types: box, slab and steps. You can set basic parameters such as step depth and step height, and when adjusting you can also enable snapping to exact value of the step depth. So in this case, when you're manipulating with object, their step depth is always exact value. If you disable this, then value is approximated. And for the manipulation, you can use this orientation button to flip stair orientation from left to right or up to left. You can very easily drag the left handle to the right and back, and this way you can change orientation. Also very useful is the fix button, same as in other tools. You can fix the dimension of the stair and manipulate with the object, then disable it and you can scale it again. So this is a very useful tool to fit stairs into any place of the building and place it and scale it there with handles precisely. Next stair primitive is a line stair object. Line stair object, you simply create stairs along the polyline. Here on this type of stair object you have additional platform option. If disabled, then steps are distributed evenly along the polyline. If you enable platform to corner option, then the platforms are created only in corners of polyline. Then you can switch between even and odd platforms. This means that the platform is created along the even segments or odd segments. With the arc stair tool, you create arc platform, arc tool platform stair objects, and finally the spiral stair object, you create the steps along the spiral tool. Same options, steps, slab or box. So together with all the primitives, you have 4 basic types of stairs: rectangle, line or polyline, arc, and spiral. Railings. We have 2 versions of a railing tool or railing generator. First, line railing. With line railing, you are drawing the polyline, and railing object or railing generator is creating railing along that polyline. Second version is the stair rail. With this version, you can attach railing generator to existing stair primitive, and the railings are generated along the stairs. When you attach railing to stairs, you can control with parameter in stair object which side of the railing will be applied, so you can disable and enable right left side of the railings from the original parent object. In this case, it's rectangle stair generator. Creating railings with existing presets is very quick. It's just 2-3 seconds. Just click and it's done. You can browse to existing presets, and if you don't find anything what will suit you, you can create your own presets from scratch. That's also very easy. Now let's go to create some railing from scratch. First, I will create this polyline. Then you can use the preset default reset to reset all the parameters. That's the easiest way. Now we have empty railing, and we can enable, disable each parameter group and see what the result is. That's the also best way how to find out how this works. So first I will enable railing as a curve. Now you can see this green curve. This is just copy of original curve with offset, and that offset is this value high. If you set this to 0, you are at the source of the tool. So railing is in fact generated from this polyline, so you can set with height parameter, you can set the height of the overall railing. I will change the railing profile from curve to rectangle. So now we are generating main railing as a rectangle. You can set the size of this main railing profile and extend. Extend means the extension on the end of each line. This is extend. If you enable subrailing, let's say again rectangle subrailing, you can fill the space between main rail and the ground or source curve with subrailings. You can also adjust the size of this subrailing profile, set the extension, and with high drift, low drift, you can position top drift and low drift. This way you can adjust the spacing of subrails, and you can set also number of these subrails. Next group of parameters are about posts, generating posts. Before I start generating posts, I will add 2 additional segments here. So you will see the difference in some parameter settings. Here we have 1, 2, 3, 4, 5 segments of lines. Now, if you enable posts, let's say with a rectangle profile, now we have 3 ways how these posts are placed. First method is the rail ends. And the post is generated only on beginning and end of the railing. The segment ends, the posts are generated in every point of the railing, and the corner ends, the posts are generated only on the points where is some angle between incident segments. So that's the difference. You can also same way set the size of these posts, and you can enable these posts to be placed as L shape. That's how I'm going to show you now. Now it is disabled because there is no offset from original rail. So if you set here offset of railing from original rail, and you enable the L shape post, then you can see the difference. This is L shape. L shape is generated from the original to offsetted railing. So this is L shape post, and you can also set the overall low of the railing, and that this way this is much more realistic now. So with L shape you can create railings which are attached from the side of the porch or balcony. Next group of options are about generating subposts. This is a little bit more complicated. I'll try to explain as clear as possible, but maybe you will need more time to understand this. So we can generate subposts same way as posts, a rectangle, circle, or curve. So let's leave it as a rectangle profile. Also it can be L shape. And if you enable posts or disable posts, it depends on how you choose this placement of subposts. So you can generate subposts inside corners or segments or rail, or along the segments, corners, and rail. Inside, now we have subposts as a corner, so I will set inside corners, means that it is placing subposts inside between corners. Along corners, it is placing subposts along, so including corners. So if you're using method along, you don't even need main posts. And you can also set how subposts are generated. The absolute way means you set the absolute distance between the subposts, and a relative way you can set the exact number of the subposts between the boundaries. And with the high drift and low drift, you can add or adjust additional position from the top and down. This is a relative drift to high-low parameters, main high-low parameters of the overall railing generator. Last group of options are about fillings. Fillings can create the solid filling material between boundaries of railing. With along rail option to low high option, you're filling full space of the railing. You can set the thickness of this filling. You can set a high drift, low drift, and start and drift of the filling. If main posts are enabled, then you can use between posts option, so filling is created between posts. If you disable posts and enable only subposts, then you can use filling between subposts. And you can enable also sub-railings. I will drift the high and low little bit, and enable also filling between subrailing, and this way the filling will be stretched only between subrails and subposts. The last option which was not explained is a segment step. It is option for post and subpost. In this case, this railing is generated with subposts, and if you enable segment step, then each this post is placed on the level of each step. So this option is specially for when placing railings on stair steps. LwCad NEXT. If you are a Cinema user and you like this plugin a little bit, then I have a great news for you. The full development focus is right now going into Cinema version. All problems with 3D Studio Max and with this port to Cinema, all these problems are resolved. 3D Studio Max port is interrupted right now, so things are moving really quickly right now. With the next version, you will get full NURBS curve system. You will get full set of curve primitives, full set of curve edit tools. All these tools already done in Lightwave, running with MeshTR system. All these will be ported very quickly. Personally, I'm really happy about things moving fast right now in Cinema. And best thing you can help is to buy a license. Also very helpful is if you do beta testing, so any problems or any suggestion, everything is welcomed. Anything is helpful. I'm very looking forward to show you more stuff in next versions. Thank you for watching this video.